Good morning, my name is Jarno. I'm the Instrumentation Market Manager for North America at Huber+Suhner, and I would like to take this opportunity to introduce our Multicoax solution called MXP, which operates up to 50 gigahertz. Just a few facts before we go into the product details about the market. So data boom, data consumption is a big topic nowadays. So if we just have a look what happened in 1 internet minute, just a few facts, like we have over 60,000 hours of music downloaded in a minute, about 6 million views on Facebook. If we talk about Google, more than 2 million search on 1 minute. So an interesting fact is what we foresee is that in 2015 it would take us about 5 years to view all the video crossing the IP network every second. So another interesting one is 5 exabytes of data is created every 2 days, which is the same amount that was created between the dawn of civilization and 2003. So just to give a quick idea what is an exabyte, is about 245 million DVDs. So that's a lot of data. Another one that I like is the world now has twice as many bytes of data as there are liters of water in all these oceans. So more data means for us more bandwidth, and also speed matters. So if we take the case of Google, 5 milliseconds of delay, which is a very tiny delay, causes about 20% traffic decrease. Amazon, another good one, 100 milliseconds delay causes about 1% drop in their revenue. So more data, speed matters, and everyone wants speed. If we take how many active mobile broadband subscriptions we have now in the world, we're counting more than 2 billion, sorry. So that's about, by active broadband, we are talking about 3G and 4G connection. So that's 29.5% of our population today. And what we have seen over the past 3 years is that it has grown about 30% every year. So what does that mean for us in terms of components? More data, higher speed, that drives the chip technology and the chip development. So increasing the speed causes actually some issues on the signal integrity. It starts to be more complex to have a perfect, like in that case, a high diagram. Now, the digital people, which were typically using the time domain, are now falling into our RF, so radio frequency or microwave words. They are using now RF connectors, asking for more bandwidth and more higher performance level. Threaded connectors, which are typically used in the RF words, are actually now not convenient, not giving them enough density on their application. So what this high-speed digital testing needs? Low loss. So the lower loss that you can achieve between your device on the test, which is typically their IC, and the test equipment. The best signal integrity they can have. So what they typically want is basically an electrically transparent components. So they want to characterize their chip on the board, and they don't want to see any impact of the connectors and the cable assemblies. They want density, saving PCB space. So they're now moving from like a relatively inexpensive material like FR4 towards more high-performing material like Rogers 3003, Nelco 4000, Mectron 6, etc. So Multicoax is really the solution that they are looking for. Of course, they need also low-loss cable assemblies, high flexibility in order to be able to handle in highly populated boards, and good phase match and good phase stable components. So the solution, our MXP Multicoax connector. It operates now up to 50 gigahertz. So we have on the market these products, which is pretty well known and pretty used, broadband use. We have increased it now to 50 gigahertz in order to cover all the new demand. It is a high density, low loss solution, and we do provide a lot of technical support. Footprint optimization, which I will, for example, discuss that a little bit further. So what are the benefits of this solution? Space saving. It's basically in one click, you have 8 or 16 channels being played. Because of the density, it allows you to be closer to your chip. So that means saving the loss of your traces. It's a reliable push-on. It's just a slide-on interface. You just slide it on. Here we go. One click, 8 channel or 16 channel being connected. Easy channel management with all the lines being numbered. So in terms of board connectors, we do offer 2 flavors, the 1x8 and the 2x8 solutions. It's a fairly small pitch, 4 millimeters. VI and pad capable, meaning that you can opt for any transition, microstrip, grounded coplanar, or strip line transition. The small size of the standard conductor, 0.7 millimeters, allow you to actually even have a good connection to very narrow traces. Surface mounted type of connectors with grounded pin in holes so that you can have a better mechanical stability. So we have 2 versions, 40 gigahertz, and as I said before, we're now coming with the 50 gigahertz. We have 2 models as well, the keyed and the non-keyed. So the keyed is actually asymmetric, so that you can only plug it in one direction. The non-coded meaning that you can actually plug your cable assembly in both ways. On the cable assembly side, we do have 3 different now type of configuration, terminated with SMA, K connectors, so 2.9 interface, or 50 gigahertz with the 2.4 millimeter interface. 1x8 and 2x8 solution being available. We are using in all our configuration the same cables, which is called Multiflex 53-02. This is a very mechanical, robust, very thin, high flexible type of cable, using a patented technology with double tape wrap outer conductor. We typically have some standard lengths, 6, 12, 24 inches, but we do customize as well depending on the application. All our components are phase matched, so meaning that every channels of the same connector or cable assembly will be actually phase matched to ±2 picoseconds. Absolute meaning that if you buy an assembly today, you buy another one tomorrow, they will still be phase matched to the same reference value. So now our portfolio extension. So as I mentioned, we started with the 40 gigahertz version, which was typically having a black housing terminated with K connectors, 40 gigahertz. We came with another version earlier this year, which has a green housing, which is basically an 18 gigahertz version terminated with SMA, so for lower speed application. And right now we are coming up and we are going to launch it this month, our MXP 50 gigahertz, which has a gold housing and is terminated with 2.4 millimeter. What is new as well in this product line is we're coming with a board-to-board solution. So whenever you have an application with a mezzanine board, so typically a motherboard with daughter cards being just plugged, so we have a 40 millimeters board-to-board connection available with 2x8. So a typical setup that we recommend is basically keeping these assemblies pretty short. One of the main reasons being that this cable is very flexible, but is, because of the diameter, pretty lossy too. So what we actually recommend is try to keep this assembly as short as you can, typically 6 to 12 inch, and use like a test lead cable, so like a VNA or SCOP type of assembly. Typically we would recommend our SucoFlex product line, which will allow you to have a lower loss and a good phase stability cable assembly. In terms of performance of our MXP, this is a typical plot that we have, where we have gated the measurements corresponding to basically the MXP connection. So we achieve better than 15 dB over 40 gigahertz. We do have as well evaluation kits. Data matters, especially for engineers, and it's often hardware or worse than 1,000 words. So we do have MXP evaluation kit that you can borrow at any time to make your own evaluation. As I mentioned before, having a great board connector is one point, but you won't get any good performance if you don't have an optimized footprint. So that is actually crucial for the performance of your of the overall solution. So what we do at Huber+Suhner is that we help you optimizing the layout to match your stack up, because thickness materials do impact the electrical performance. So we do have a process, having a simulation form, where you give us basically your stack ups and the type of routine or any restriction that you might have on the manufacturing side, and we will come up with like an optimized footprint matching your specific boards in a Gerber and DXF file. So this is actually time saving also for you. So just a quick presentation or view about a typical transition that we use. We have 3D EM, so electromagnetic simulation tool, and we basically optimize the crucial part, which is coming from the coaxial to the planar mode. So just to sum up on this MXP, operating up to 50 gigahertz, available up to 16 channels, so 16 channels in one click. You get shorter lines, so you save on the loss, because we all know that the losses at higher frequency on the boards are even much higher than a coaxial cable. Space saving, easy management, and overall that's a cost saving. So if you have any questions, my name is Jarno, and I'm based in the US, so do not hesitate. And thank you to our RF and Power for inviting us today.